Good morning, everyone. Thanks for coming to this talk. If you're interested in Unity development, plugins, audio, I hope you like what I have prepared for you today. So first of all, I'm going to introduce myself a bit. I've been working in game audio for a few years now for different companies here in the UK and also in Spain, where I'm from originally. I participated in some games, you probably have heard of them, FIFA, Dirt, Guitar Hero, as well as Space Lords. And I've been an independent consultant since last year. What I do right now is R&D services for companies in the audio and the game industries as well. And as a personal thing, so you can get to know me a bit better, I also like to do aqua fitness a couple of days a week, so I'm missing it because I'm here this week in London. But I would also like to talk a bit about my motivations for this talk. So, first of all, I think that it's been an increasing interest lately about the game audio plugins development. I also find that there are starting to be new opportunities for companies and for people that come from a more traditional audio plugin background in order to bring out new game audio tech as well. And also, as part of my motivations, I feel also that game audio technology at the beginning can be challenging for newcomers or for people entering the industry. So I hope that this talk will help you to have a bit of better understanding on how to get started. So this is the outline, what we are going to cover today. First of all, I'm going to go through an overview of the different approaches for building plugins, also related to that, the effects and synthesizers in Unity. As we will see, there are different ways of doing that. So we'll cover it at the first part of the talk, and then later I'm going to speak about the development details of a plugin from Voctro Labs called Voiceful Characters, which is a text-to-speech plugin. So, and then we will have some Q&A. Okay, so if you haven't heard about Unity, what is it? So it's one of the most used game engines for different types of games, also AR and VR experiences. About 50% of games that are made today are made with Unity. So that gives us like a good user base in order to bring out and to implement our audio tech in that. As part of the audio engine is used the audio middleware Fmod, so that's part of the audio system built in the engine, which allows us to create plugins and to extend what is already available in Unity so that we can expand and do our own reverb or effect, whatever we want for that. So, as I said, at least we can find 7 different approaches for creating synthesizers or effects for Unity. There are different ways of doing that, so there are probably even more for doing it, so we just want to go through the details of that. Of course, if you want to offer some features or functionality, that will depend on the approach that you pick for it, so and will also determine the amount of code what you will need to maintain in the long run as well. So let's start by the first approach. So we have the native audio plugin SDK. This is probably the straightforward way if you look for how to build plugins in Unity. If you Google for it, you will find the documentation in the Unity manual related to this SDK. The way that it works is that we create dynamic libraries that we can build for each platform and then use them somehow similar or close if you're familiar with the VST format, also having parameter support so that we can change parameters in real time for that. And as I said, it's probably first choice or the closer choice if you're familiar with other plugin formats in other fields as well. So second approach is to build a native plugin. That means that we can have a dynamic library where we can expose a C++ interface, and then we use that from C# scripts via what is called the interop services in Unity. Advantage of it is that if we have already code base or we have already a library that embedded in a plugin, we can just add a wrapper on top of it and start using it from our Unity application. So that was also the choice of the plugin that I mentioned earlier. Voiceful Characters uses this approach because the company wanted to use it more straightforward way instead of implementing or adding more code, which is also related to the first approach. So we don't have real-time parameter support for that, even though there are workarounds for it. We can use it. So third one is to use plugin frameworks and generators. So we have different options available. Probably you've heard already from Use or Faust or even Heavy Compiler. All allow exporting plugins from this framework so that we can have, for instance, a Use exporter for Unity plugins, which was added, if I remember correctly, this year as well. So at some point it simplifies our way of building plugins because it's about like a wrapper that we have on top of the native audio plugin SDK. So you want to develop for different platforms that also can simplify the process of doing that. So approach number 4, we have a way of doing audio processing and doing synthesis as well from C# scripts. So C# is the de facto language for Unity scripts. So we have a way of writing our DSP code in the C# side, and that will work if we just implement the audio filter read callback. Problem is that obviously we are in the manage side of things, so performance can be an issue due to things like garbage collection, but yeah, but still we can build scripts that can be shared or distributed. So this is a quick example of how this works. So basically, having here in this slide a noise generator, which is implemented as part of the base class mono behavior in Unity. And then, as we can see, we have the on-audio filter read implementation, which is basically to fill a buffer of samples and given a number of channels as well. So we do that in an interleaved fashion. So here in this example, just fill in with numbers between floats with -1 and 1. And as I said, if we attach it to an audio source, we can hear the noise. So next approach is to use audio languages. So probably you have heard of some of these. There are ways to integrate languages like Chuck or Super Collider, as well as Pure Data as part of PD. There are projects that give you a way to embed the language in the Unity application and use it from C# scripts as well. There's also actually a demo here at ADC this year, which is using Tunity, the Chuck in Unity from Adrián Barahona. So there's doing procedural audio models for that. So I think it's a good approach and also interesting view of how to run our DSP code within Unity. Sixth approach, getting there, okay? We can also build game audio plugins. So we have an integration of the audio middleware like Wise or Unity. We can build plugins for it and then use the integration within the engine. So if you are targeting users that are also making integration of the middleware in their projects, so that's a good way to bring out your plugins as well. So it's probably the most complicated of all. We will need to add more code in order to handle the middleware and to handle the API related to that, and also the integration. So still a valid approach, but as I said, it's also feasible. So last approach is more new. Recently, actually, we have the DSP Graph API. This was newly introduced this year. So basically, it's available as a user package. What we can do is making our DSP processing in the C# side, and then leverage other systems from Unity, like the job system, so that we can distribute the processing that we are doing across cores. So that's a nice thing. And also another advantage is that we can build the code in C# and then compile to all the platforms that Unity supports. So we don't need, in this case, to handle the different dynamic libraries that we have to compile for each platform. All right, so let's start then second half of the talk, which is going to be about the Voiceful Characters plugin. It was released this year in June by the company Voctro Labs in Barcelona. I've been collaborating with them in order to bring this product out there. So it's basically a text-to-speech engine that uses AI technology, in particular deep learning, for generating audio, for generating speech. There are 3 versions of the plugin depending on the features that are available and also the number of presets, covering like Free, Light, and Pro with different tiers. We also have their configurable parameters like genre, motion, speaking speed, different things for that. So just to talk a bit about the background, where does this come from? So the company has different algorithms and different libraries, so to speak, for different things like speech synthesis, singing generation, morphing, analysis, alignment to lyrics, and also time scaling. That's part of a general SDK and also Cloud SDK, also permitting to work and deploy to WebAssembly. So that's part of the Voiceful family. So the company wanted to use the synthesis library and then embed that and then pack it into a Unity plugin. So actually how that works is somehow simple, so there are different layers. So these are some of the details of how that works. So first of all, left-hand side, we have the Synth lib, which is our low-level plugin DLL that's written in C, C++, that's compiled for each platform. On top of that, we have the Synth Unity lib, which is a C# interface that is going to call the low-level plugin, and that's made in Manage, so that's also DLL. And finally, we will have the client code, which is the one that will use the C# interface. So there are somehow like 3 layers for that. So let's start by having a quick look how the integration of the lower level interface works with the C# side. So this is a really quick example. I've taken it from the code. It's still not complete. On left-hand side, we can see that we can export an API for instance, in this case, like getting the library version. So really sample code. Obviously, we are allocating memory here. We'll need another way of deallocating that later. But the important thing I wanted to mention here is that we are having the mapping of the get library version on the C# side by having the DLL import attribute and referencing the plugin DLL by name, so that we can get from C# the version of it. So that's a really high overview of how the plugin works. Another example of the API that is exposed, this is basically to configure the synthesizer. So we have different parameters like buffer size, sample rate, also the synth handle, and even the voice model that is used in order to generate the audio. So same way we have also the DLL import in the C# side, and then we can call the function from the dynamic DLL. Okay, so this is another example, for instance, how we can use the C# interface from the client script. So the user can just instantiate a Synth Unity lib object, and then if we have it attached to a game object in Unity, we can just look for it and then call the get version function. So again, just a simple example how it works. We do that for each of the parameters, for instance, doing that. And also the creation of the audio, which I'm going to mention here, which is as part of the C# interface. We compile that to a managed DLL. We can do that from Visual Studio, both on Mac or Windows, using the class library Net Framework 3.5. And then since we wanted to hide some information of the DLLs, and since it's possible to disassemble them with tools like Eyal Spy, we decided to use a third-party solution for doing some obfuscation and name mangling, so to speak, of the different functions, different values of that. That is the library Obfuscar, which you have available on Windows, and it's under MIT license. So, okay. This is also related to how we build the plugin. So we wanted to offer a way to create some demos for the people to try it out. So there was a need for having some kind of application state so that we were able to, see this demo has expired or not within the trial for that. So we also used another third-party solution, which is called Secure Player Prefs. That's built on top of Unity's player prefs, so that we can store different values or different state for the application. Then this library, what it does is to encrypt that so that we can also store that more safely. Not less important, also related to the distribution of the plugin. So what we have done is to create Unity packages. This is a way of doing it in Unity. So basically, we put all our plugin content, also documentation, sample scenes inside the same folder, and then we create a Unity package for that, so that users of the plugin, they just need to import the Unity package and then start using it from the game project. So on top of that, we also have documentation, obviously, since we have a public API for the plugin, so we want the users to get up to speed quickly and to use it straight away. So there's also documentation for that. And as part of it, as I said, we have different sample scenes. So this is how the plugin looks for the pro version, professional version, which allows to tweak all the possible parameters. So we have, as you can see here, ways of tweaking the gain, page speaking speed, the different timbre, and as well to apply different effects. We are using the built-in effects from Unity in order to do that. And with this scene, we can also set parameters, as I mentioned before, like the style from angry, happy, sad, so different emotions, and even change the handle for that, and as well as managing some presets so that the user with the sample scene can tweak different parameters, preview them, and then hear the result for that. And of course, we have a text field at the top where we can enter our phrase, and then it will synthesize the result. So this is part of a demo that is also available at the URL down there, and it's part, as I said, of the plugin that we have available for that. So I think that's pretty much it from my side. So thank you very much for your attention, and I'm happy to answer any questions.
Hi.
Sorry,
I guess there felt like a. So the industry standard for game engines is generally tend to use middleware solutions. But if that's like the most complicated solution for most complicated approach for creating audio plugins, where do you see it going? Do you think that in the future, if there are more audio plugins available for the engines, that audio designers will be more willing to use the native audio engines?
Yeah, that's a good question. I think it's part maybe of the fragmentation in the industry. So there are projects that use middleware while others not as well. So I think that's my impression as well. There is an increasing usage of middleware integration with Unity as well. That's in part because they implement a workflow that is also known to sound designers. So sound designers that are used to for instance, like the wise authoring application then are then familiar with it, so it reduces a bit of dev cost for that. And also the middleware solutions in general are more feature rich somehow, that what Unity comes with as a base. So I think it's probably for plugin development, maybe there were going to be bigger market for middleware because probably more people are using it. I don't know, did I have answered your question?
Yeah, I think it's interesting to think about where that's going to go, really. I think sorry, I should use this. I feel like, you know, that's where the really big gap is for the plugins for Wise and for Fmod.
Yeah.
That's what I would, because I'm an audio designer, so that's what I would really like to see.
Good.
What's the licensing model? Do you get an income for every unit shipped to the actual players, or is it a flat fee?
What do you mean about the Voiceful Characters plugin I mentioned? Or
well, possibly in general, but how do you actually make money on the plugins?
Oh, for the plugin. So, well, maybe I can speak about the actual plugin that I mentioned here. So there are different tiers. So depending on the budget of the company, you have a different plugin version. I can't remember right now what's the tier exactly, but there is a free one, so you can use it up to 2 projects for that for free. That's limited to 3 presets, and then there are other versions like the Pro one, as I said, that you have full control of the preset for that, and that's different pricing. So, yeah.
Do you actually get an income for every unit that the developer sells?
Do you mean like percentage, like royalties or things like that? Not for that, no.
G'day. I was wondering what your thoughts are on using the C# based, like on audio filter read and the jobs based system in terms of writing that stuff in production code, and how safe you feel it is. Like, is there a danger of the garbage collector jumping in the middle of an on audio filter read call and giving us a dropout?
Yeah, obviously, as I said, being in a C# side, you are limited by the constraints of that. Like, that's typical in Unity development as well. So garbage collection can kick in, and then you have frame rate dropouts and things like that. But as I said, you have the other ways of doing it, like more in native code, so you can have more control of it. And I think the DSP graph that I mentioned before is also very exciting because of the load processing that you can distribute across cores. I think there's going to be a leap forward for Unity development in that sense, and there is also maybe possibilities of that you can create certain scripts on top of that and then share it or make a product out of it. So yeah, I think it's interesting.
I'm not sure I understood. I saw Juice has an integration for exporting plugins.
Yeah.
So what are the extra steps required for you to take a plugin that you have it in Juice and actually put it somewhere on a marketplace or something, like, say, a basic effect or something?
Yeah, to be honest, I haven't used yet the Juice integration for that, but my understanding is that you create another platform or exporter in the producer, and then that will generate for you a solution where you can build the plugin from. That's my understanding.
Like the Unity package that you were just...
Sorry?
Like a Unity package, or it will build you a Unity package?
I'm not sure if that's a Unity package, but I guess that is going to at least generate for you the dynamic library that then you can load in the engine.